mathematics class. Today in our math class, I'll be talking about modular arithmetic. Now let me start with modular arithmetic first. So we'll probably talk about binary operations too. Modular arithmetic. Now the concept of modular arithmetic is very, very simple. It is a way of finding multiplication of numbers, addition, or anything that you want to do for numbers. The concept modular arithmetic, for this level which I'm going to be talking about, I won't go beyond what this level requires from you, is that, for instance, let's say I'm taking an operation in mode n. If I'm taking an operation in mode n, now one thing you should know is that none of my results, if I'm taking the operation in mode n, none of my results will be up to n. They can never be up to n. At least my result will be from 0 to n minus 1. That's how modular arithmetic operates. No matter how big the number is, then but if I multiply the two of them together, or I do anything to the two of them, I will always come back to what? I will always come back to n. So that's just the basic thing that modular arithmetic is saying. Now, one of the properties in mathematics that really satisfy this modular arithmetic that we've not take note is the concept of angles. You realize that most angles, we used to think that the biggest of these angles that we can have is 360 degrees. Whereas we can have more angles. There can be an angle of 420 degrees. But if all angles can be changed back to mode 360, we can always take all angles back to what? Mode 360 degrees. And what do? It's a very simple thing. You see that this is a very, very simple concept that you don't need much time to learn about it. Let's see. If I'm in mode 9, let's say I'm in mode 9. Now, the set of numbers I can find in mode 9, they are 0, 1, 2, 3, 4, 5, 6, 7, and 8. These are all the numbers that I can find in mode 9. In fact, now this mode 9, this 0, 1, 2, 3, 4, 5, 6, 7, 8, each of them represents a class. Which implies that there's another number that belongs to this class, there's another number that belongs to this class. So every number that falls after this, they belong to one of these class. So if I have a new number now, after 8 we have 9, but 9 cannot be there. 9 falls here in class 0. 10 will fall in class 1. 11 will fall in class 2, and so on and so forth like that. So all these numbers here represent a class, which implies that if I get any value and I want the answer in mode 9, then all I have to do is what? This very simple operation. For every value that you get, let's say k is the value that you have gotten, then you can always write k as 9 multiplied by n plus r. Now, n is a natural number. Then r is the class that number will belong to. In fact, that's your result. That remainder is your result. For instance, in this place, if I pick 4 times 5 will be equal to what? 20. I'm performing this operation in mode 9. Let me write it. I'm performing 4 times 5 in mode 9. Now, if I'm performing 4 times 5 in mode 9, that implies that I cannot have 20 as my answer. 20 will be wrong as my answer, because no number in mode 9 should be what? Should be more than, or should be even up to the number. Now, what do is that we divide 20 by 9. If we divide 20 by 9, you will realize that 20 divided by 9 is 2. So that's 2, and it is remainder 2. 2 into bracket 9, then remainder 2. So this implies that 4 times 5 in mode 9 equals 2 in mode 9. So that is as simple as that. That is 20 as we have gotten it, it's not amount to anything, it's just 2 in mode 9. And mind, it's not because I have 2 and 0, that's why I have 2 here. No, let's see another number. Let's say we have 5 times 7 this time around. We have 5 times 7 in the same mode 9. So 5 times 7 in mode 9 will be equals to, on the number the 5 times 7 is 35. 5 times 7 is 35. But you realize that 35 is not an element of mode 9. So what do we do is that we divide this 35 by 9. If we divide 35 by 9, what do we get? We get 3. That's 9 times 3, that's 27. So we have 9 times 3, which is 27. Then 35 minus 27, that's 8. Plus 8. So which implies that, so what's our answer now? Our answer equals to what? 8 in mode 9. So basically all you have to do is what? Divide that number in that mode, divide whatever result you have gotten, divide it by the mode you are, then the remainder will be your what? Will be your answer. So that's just basically what we do in modular. So even if it is addition, if you have 5 plus 6, 5 plus 6 is 11. So 11 divided by 9, that's 1, remainder what? Remainder 2. So the answer is what? The answer is, so 5 plus 6 in mode 9 is what? Is 2. That's what we do in modular arithmetic. 7 plus 8 in mode 9, that's 15. But not 15 cannot be the answer. That will be 15 divided by 9, that's 1. Then remainder what? 6. So 7 plus 8 in mode 9 is equal to what? Is equal to 6. That's exactly what we are talking about. For instance, let me take another mode. Let's say you have mode 5. Mode 5 now. What are the numbers we have in mode 5? We only have 0, 1, 2, 3, and 4. Now, even let's say I'm even taking another operation. Now I'm not saying multiplication, I'm not doing addition. Let's say I want to do powers of these numbers. Now 4 raised to power 2 in mode 5. What will it be? 4 raised to power 2 in mode 5. What will it be? That will be 16. But 16 cannot be the answer. 4 raised to power 2 is not 16 in mode 5. So what do? We just have to do 16 divided by 5. That's what? That's 3. Remainder what? Remainder 1. So which implies that 4 raised to power 2 in mode 5 is what? Is 1 in mode 5. So that's basically how we perform the operation. So 4 raised to power 2 that is supposed to be 16 is 1. Just 1 in mode 5. And that's it. So, and if you get, if for instance now, if I do something like, something that will give me 10, if I combine anything that will give me 10 here, is there anything that can give me 10 here? Yes, I can get something that gives me, if I had everything here, 1 plus 2 plus 3 plus 4, the addition of the 4 of them is 10. But 10 in mode 5 is 0. The value of 10 in mode 5 is what? Is 0. That implies that the value of, if I'm dealing with mode 8, the value of 64, as big as it is in mode 8, will be what? Will be 0, because the remainder when you use 8 to divide 64 is what? Is 0. So that's basically what we have in modular arithmetic. So let's compute a multiplication table now in one of these mode. We want to compute a multiplication table in mode 5. So if we are in mode 5, then mode 5 will have 0, 1, 2, 3, 4. Then this one as well will have 0, 1. Let me not include the 0 class. Let me just put 1, 2, 3, 4. 1, 2, 3, 4. Now let's draw our table. Mode 5. We are doing multiplication in mode 5. So let's see what will happen. Of course, 1 times 1, that will still remain 1. 1 times 2, that's 2. 1 times 3, that's 3. 1 times 4, that's 4. That one is nice. Now 2 times 1 is 2. 2 times 2 is 4. But 2 times 3 is 6. That's where the problem starts. You cannot write 6 in here because we are in mode 5. So 6 in mode 5 is what? Is 1. Because what? When you divide 6 by 5, you have 1 remainder what? Remainder 1. So 2 times 4 is what? 2 times 4 is 8. So what is 8 in mode 5? 8 in mode 5 will be what? Will be 3. 3 times 1 is 3. This is okay. 3 times 2 is 6. So 6 in mode 5, we've already gotten that. That's 1. 3 times 3 is 9. 9 in mode 5, that's what? That's 4. Then 3 times 4 is 12. 12 in mode 5, that's 2. Because 12 divided by 5 is 2 remainder 2. Then 4 times 1, that's still 4. 4 times 2, 8. 8 in mode 5, we've gotten that to be 3. 4 times 3, that's what? 12. 12 in mode 5, we've gotten that to be 2. And 4 times 4 is 16. 16 in mode 5, that's what? That's 1. That's 1. So this is our multiplication table in mode 5. So in case you hear the question and you asked to just complete the table, you are doing a modular arithmetic in mode 5. So this is what modular arithmetic is all about. So all you have to do is what? When you complete whatever thing you have to complete, maybe square, powers, any power, multiplication, addition, and everything. Once the number exceeds the kind of number that can be in the mode, from mode 5, you will start from 0, you stop at 4. So once the number exceeds that, then you know that you have to divide it by that mode that you are taking. The remainder will be the result. So I believe this is very, very clear now, and this will be the end of the discussion on modular arithmetic. It's as simple as that. Thank you for watching.